Hi, it's Jan Beta, and through my immeasurable influencer powers, I was able to acquire a new digital microscope that we're going to take a look at today. And we're also going to do something useful. We're going to solder up an RGB to HDMI little circuit board for the Amiga. So this microscope is a Tomlov TM4K-AF Flex. And we're going to take a look at what this can do, and then we're going to actually use it a bit. But first of all, there's a little disclaimer. Full disclosure, this thing was sent to me for free by Tomlov to keep and to make videos with and to work with. And after some negotiations, Tomlov also agreed to provide me with a discount code. So hopefully, if everything works out, there are going to be links to this exact microscope in the video description with a discount code that gives you 10% off of the price of this thing, should you decide to buy one of these after watching this video. And this video is going to be a hybrid between kind of a review, but mostly just using this thing and seeing how well it works in a real-life scenario, just soldering up some surface mount PCBs. And if you use one of the links in the video description to buy one of these, I'm also going to get a small little commission for every purchase made through these links. So I thought this would be okay to do. I don't do these very often, but I wouldn't be able to afford one of these because I basically don't have a lot of money. And I always wanted one, so I took this opportunity. Hope you don't mind, and I hope you don't think I'm a complete sellout now. I try not to be that. So let's take a look at this microscope briefly. This is a Tomlov TM4K-AF Flex. Flex is basically this arm that it has that can clip to any desk or table or maybe something else. This is very versatile. There is a version with a slightly larger screen. This is an 8-inch screen, I believe, and this can do 4K resolution. The screen is only 1280 by 800 pixels, but that doesn't really matter. It looks pretty crisp, as you can probably see. The great feature that this has that kind of sets it apart from some other microscopes is that it has an autofocus button here. So you just hit that and it focuses on the part that's under there. That's actually an RGB to HDMI board. And one of the features that this has is that it has a built-in battery, 2000 milliampere hours, which should be able to power this for some hours. I haven't really tried draining the battery yet, but this makes this a really nice portable option. You can just fold this arm up, basically. There's a round stand. This arm construction here is basically like a monitor stand, so you just screw it with a clamp to your table, and it is pretty sturdy. My table is a bit wiggly here, but this holds in place good enough to be usable even on my wobbly table. Yeah, screen quality looks really good. There's not much delay in movement, as you can maybe see. And this should be totally usable. I haven't used it yet for anything proper to actually solder, but we're going to see how that works out. This also comes with a little ring light that you can put on here. Basically, this whole thing here is the microscope. You can just take this out. This is currently hooked up to a USB port. Just going to remove that. Powering it down. Yeah, this is the microscope part. Comes with a lot of connectivity. USB output, actually, to power things like extra lights or something that requires 5 volts output. It has a little reset switch in case the firmware in this thing hangs itself. It has USB-C for power, for charging the battery and for powering it. It works while plugged in or without being plugged in if the battery is charged. Has a little micro SD slot. It can actually capture 4K resolution video and 52 megapixels pictures of what you are magnifying. And it has a mini HDMI, I believe is the format here, output. So you can hook it up to an HDMI screen of your liking as well, a larger screen if you prefer that. The USB port also works as a webcam-like device if you hook it up to a PC. So all the connectivity you would ever need, I guess, at this point in time, until somebody comes up with something else. Yeah, and putting it on here, basically just you put it in here, and there's 2 screws to fix it in place, which holds it pretty nicely. And setting this up was actually not that difficult. It's, as I said, basically the same as one of these swiveling monitor stands. And yeah, off we go. Boots up pretty quickly, like 10 seconds or 5 seconds even. You can have manual focus, you can have autofocus once, or you can hold down the autofocus button to have continuous autofocus. You have a little light here that you can adjust with this capacitive touch thingy here, which is pretty neat. It also comes with a remote control, which I haven't really tried yet because I'm just sitting next to it for most of the time I'm using this. A ring light is included that clips on the bottom end here. Didn't really need that yet because my lighting here, because of the video lights that I have set up anyway, seems to be very much enough to use this. I might try that later in this video. Magnification depends, of course, on how high you set it up, but it's pretty usable for what I want to do with it, which is basically SMD work at this scale. So yeah, that's what it looks like. This working distance, actually, it focuses to a point of 1 centimeter away from the object up to, I think, 21 centimeters is what they claim. The autofocus works around 2 centimeters away from the object, and then you have manual focus as well that you can adjust with these plus and minus buttons, but I didn't need that yet. And yeah, this is of course a much nicer working distance than with one of these super cheap USB microscopes, although they work fine picture quality wise. This is of course a huge step up. And as you can see, I have set this up to 1080p at the moment, just because the lag is a bit less with 1080p, obviously. But you can, in this menu, you can set it up to all kinds of different things. You can have playback on here for the videos you've taken. You have automatic white balance, and you can adjust the monitor brightness. You can put the picture in black and white if you prefer that, or a negative picture. But yeah, for normal use, I'm just going to leave it at that, I think. You can adjust contrast, saturation, sharpness. You can mirror the image. You can set the frequency to other things. Also, the shortcut setting sets this OK button to photo, video, or freeze picture. You can set the picture resolution to 13 megapixels or 52 megapixels and the video resolution to 4K at 30 frames or 1080 at 60 frames, which I find more usable. So yeah, LCD brightness. There's a couple of languages in here. I just left it on English. It has a built-in clock, obviously, for tagging your files that you take with this. And yeah, it's pretty concise and relatively self-explanatory. You can have a crosshair in here, and a ruler, and things like that, which works pretty nicely if you need that. I'm not going to need that ever, I guess. But yeah, this is what this thing can do. And this is now a 4K resolution. It's not much difference, but you can see some tearing there, maybe, in the picture. Reaction time is still super fast. So this shouldn't be any problem at all to work with this. I'm just setting it up to 1080p, I think, because that's the resolution I use in my videos, actually. So you wouldn't be able to see the captured 4K video properly anyway, so I'm just using this. And you can just hit the menu button to get out of the menu. And if I hit OK now, this is set up to take video. I can actually take video of the object that I'm looking at, which we are going to do in a second. Yeah, build quality of this, there's really nothing wrong with it. It is made out of plastic. The arm is all metal. It has some nice cable channels here, just like your regular monitor arm. I guess that's what it is. They just repurposed it. And there's a height adjustment here that feels pretty solid, and the autofocus is pretty quick. Works pretty well if the lighting is good. There's nothing really bad I can say about this at this point. We are going to try to use this, and I haven't really used any proper digital microscope yet myself, and also I haven't done any proper this scale of SMD soldering, so maybe we're all in for a treat, and maybe I fail miserably. That's nothing you can blame on the microscope, really. It seems to work really well, but I'm not used to using something like this because I just got it a couple of days ago, and I've not tried actually using it, apart from looking at things and checking out the menu functions and things like that. But yeah, you're going to be my witness soldering an RGB to HDMI. And I think that's what I'm going to do now. And then we're going to maybe talk about more features of this. I think I covered the basics. The price point of this thing is between 200 and 300 euros, if I'm not mistaken. You are going to see if you click on the links in the video description. So it's not a super high-end professional model, but more aimed, I guess, at the ambitious hobbyist like I am, maybe. Maybe you are too. I think this is going to be a huge step up for me. And I actually shied away from doing any proper small-scale SMD work because I didn't have a proper microscope. And now I have, so let's see what we can do. And I'm going to capture some video on this and try to show you what I do in glorious 1080p 60 frames captured on this microscope. So this is the RGB to HDMI for the Amiga. This actually plugs into the socket where the Denise graphics chip sits, and then the Denise goes on top, and you use a little Raspberry Pi Zero to convert the digital signals from the Denise chip to a proper HDMI output. These things work really well. There's not a lot on here, just a couple of logic chips. There's also a version that works even better now with a CPLD, but I have circuit boards for building this exact model, except for I have a slightly newer version, the next version after this, basically, that has a little jumper on the backside to set it up for OCS and ECS Denise chips, because the timings apparently are slightly different. This is an open source project. I'm going to link that below again. Haven't really looked into that for ages, so things might have improved considerably without me knowing about it. So I'm going to try to build this exact thing from some PCBs and components that I bought years ago, I believe, when I planned on getting a proper microscope, but didn't have the chance. And now I have one, and it's finally time to try to solder these up. So while this video is actually not sponsored by PCBWay, you probably know that PCBWay does sponsor quite a few of my videos, and I have contacted them about making these for me, and I made some purple circuit boards here. I think I have 10 or thereabouts. So these are all this, basically, just in purple, with one added jumper in the back that is used to switch between the different Denise models. So let's see if we can build one of these on camera, and I'm probably going to build the other ones off camera sometime. So this is what this looks like. Purple PCB, because why not? I like purple PCBs. And this is the extra jumper I was talking about for the Super Denise, which is the ECS Denise, and the regular DINs. It's just a little pin header here with a jumper that you set according to your Denise model. And then we have these pads for our super tiny logic chips here and some through-hole stuff for the connectors. And here's some voltage regulator, I believe, and a resistor and a capacitor. And some more capacitors on the chips to decouple the voltage supply to those. Let's try to do this. I've actually never ever soldered a tiny chip like this, so don't laugh if I do something wrong, and please don't take this as a tutorial about how to properly SMD solder, because I have no idea how this works, really. I'm just going to try, and you are going to see what I do. So, yeah, I actually messed up one chip by building solder bridges. You really need very, very little solder to solder these components, much less than I anticipated. And this is my setup now. I set up the ring light. I am going to start recording here. And yeah, we are going to watch this on the screen together. And I started up my soldering iron again. I'm just going to tag this chip on one end, I think. We are going to the soldering iron looks massive here. We are going to make this happen. I'm just going to add flux to this board, and as you can see, it's pretty clearly visible. We are going to position this nicely, like so. We are going to put a bit of solder on our tip. You need really steady hands for this. Then we're just going to drag it over here. And we already have a blob of solder there again. Can kind of pull that out, I think. Yep. That looks relatively clean. You could use a smaller tip, of course, but you don't have to. Yeah, that looks good. That side of the chip should be soldered nicely. So let's try the next one. You really, really need very little solder on your tip. A bit more. There we go. That's soldered in quite nicely, I guess. That went relatively well. Let's try the next one. This is the one I put some bridges on and bent some pins on, actually, before. And thankfully, the battery in my camera died, and I also found out that my charging cable for my camera broke, so I didn't record that at all. But this looks relatively good, and we don't have any solder bridges that I can see. So let's move on to this one. That went well, so we're going to add some flux here. And of course we are going to have to solder the little capacitor next to it as well here. So this here. Can position it something like this. The microscope definitely helps seeing this at all, but you still need some skills. Yeah, something like that. Now we're going to put a tiny bit of solder on our soldering iron. It's already way too much. holding this down. And dragging. Okay. Actually, looking quite good. Okay, same on the other side of the chip. And we build a bridge there. Yeah, that's too much solder already. But yeah, that looks reasonable, I think. Yeah. Wow, okay, this is more difficult than I thought, but it's still not quite so difficult with this microscope. Okay, let's solder the last chip, which is a bit smaller even. Same form factor, but less pins. So that goes here. That's U1. That should be a piece of cake compared to the other one. But we need even less solder. Okay, this one goes like this. We're going to add some flux to the equation here. Lots of flux, actually. And we're going to put the chip on there. Nice and centered. There we go. That doesn't look too bad. Holding the chip in place with my tweezers. And dragging some solder on it. And trying to drag the solder out. That was too much. Yeah. Okay, I think I'm already getting the hang of this. Try the other end. Too much. That actually didn't go too badly. There's a little blob there. But there we go. So you can actually see quite well if you build bridges. And yeah, it doesn't look super awesome, but I got better. You can actually see some progress here from this chip here to the next one. Well, this side doesn't look great, but the other one does. And this actually looks pretty clean already. Okay, so the next part would be, I think, this voltage regulator part here. And we're going to add some flux. And then we're going to add our part. And basically do the same thing. Over and over. So, yeah. This is actually more difficult than the others, I think. So let's see if we can hold it in place and drag it. There we go, that went well. Okay. So the other side should be much easier now. Yep. Oh. Yeah, that actually looks good. So we have C4, which is a larger capacitor, and R1, which is a resistor. Flux on the capacitor position there. That's our capacitor, C4. C4, Jamie wants big boom. And these are literally, you could like breathe them in. These are so tiny. Also my tweezers are slightly magnetic, which doesn't really help. Yeah, let's just slit in place there. which is what these do actually. And now I tombstoned it. That's not good. Yeah, no. That's not how you're supposed to go. And I lost it. There we go. Yeah. I mean, it contacts the pads, I guess. It doesn't look great, but it should do functionally. Okay, now we have some resistor there. It's even a bit tinier, I guess. I need some other tweezers that are not magnetic. These don't help. They worked for the chips, but for the smaller components, it really doesn't help if these are magnetic. So, yeah, little resistor there. That fell. Oh, God. It's so tiny. There we go. That's our resistor. And as you can see, the surface tension of the flux there is enough to hold it in place. Okay, let's solder it. Yeah, that should be in. Not quite straight, but it's okay. Ah, it's definitely making contact with the pads. So now C1 and C2. This is the size of these. These are even smaller compared to the other capacitor. I'm sorry. I keep saying resistor. We can try to use some hot air to actually blow them into place. So the surface tension of the solder is actually going to pull them. That looks good. Okay, the other end. Yeah, that's in place somewhat. Let's try the other one. C1. We have 3 of these. Yeah, that doesn't look great at this point. Yeah, that's a bit better. But we can use hot air probably. I'm going to try that just for giggles in a second. I'm just going to put C3 in. Electrically, this should be fine at this point, but it doesn't look great. So maybe with some use of hot air, we can nudge it into position. Probably should have done these before the chips, but I'm a noob. This requires more patience than I have. Okay. Yeah. Bit at an angle, just like the other ones. But I think what I want to try is to put some flux on there and then nudge them into position. I've seen Louis Rossmann do that. Maybe it works. The microscope, by the way, works pretty well. It doesn't really move at all. Ah, there we go. That looks nice. Okay, it really works. Look at that. Ah, beautiful. Kind of looks as if I knew what I was doing. Okay, very cool. There, it's slid into place. Nice. It actually looks reasonably good. So this actually kind of looks like I knew what I was doing, which I was most definitely not. But yeah, I'm really pleased with the result. I hope I didn't toast anything too much, which is, of course, if you're using hot air and a big soldering iron and things like that, that is always an option. Failure is always an option, which is the second Mythbusters quote I hit in here. We're going to have to do some non-surface mount through-hole stuff. And then we can try this. So the way we do this is, I think, to start with these pin headers on the bottom, soldered from the top, and then solder the stuff on the bottom. Yeah, I think that's the way this goes. And yeah, these have one shorter pin and one longer pin. The longer pin is going to go to the bottom to be put in a socket, in the Denise socket in this case. And we're going to have to shorten these because, of course, I bought longer ones. So, and I think we could put these in a socket while soldering. We are going to need one of these anyway, later on. Just going to put the longer pins in there. These are going to be soldered in, and then we can solder the other stuff, I guess. Just using flux for this as well now, because it helps. This goes here. Yeah, we can remove the socket now. Okay, good enough for me. The socket, the 48-pin socket first. And there's not a lot of room to solder this, but at least we can lay it flat here with this. So that's what I'm going to do. And we have to take care that we don't touch our pin headers too much. Could of course do this under the microscope as well, but it's not really necessary. My eyes are not that bad yet. Thankfully. I am short-sighted, which actually helps with stuff like this. But I'm getting a bit far-sighted with age currently, so my eyes are not going to be getting better over the years. So that's in. Yeah, I guess we can do the pin header next, the Raspberry Pi header. So these are all standard parts basically. And there is, of course, a bill of materials in the GitHub. Yeah, I think I can solder that in. Yeah, that looks straight to me. Okay, one last little connector on the side here. And then we're done, maybe, in case this just works. That looks straight. That should be that. Now we only have to clean it up and actually give it a test. It does look surprisingly good for something that I made and for my first try at proper SMD soldering. That's what I just made using my new technology. And this is the original one that I think Copper Dragon soldered up in a similar fashion for me. So I wouldn't have to do any SMD soldering myself, risking this not to work. Yeah, we are going to, or I am going to clean this up properly with some PCB cleaner. And then I'm going to find myself a Raspberry Pi Zero and an Amiga to try this in. So let's see if our little RGB to HDMI actually works. I found an Amiga and a Raspberry Pi Zero. And we're going to put this in there. And this has an ECS Denise, so I set the little jumper in the back to ECS Denise. Here's my Denise chip. And we need to pull that out. So this goes in here facing the way the original Denise faces, of course, which is with the notch facing here, and the Denise is already sitting in there. Now we need our little Raspberry Pi to go on there, like so. We have to put a little SD card in there, of course. And I just installed the latest version of the firmware on there that I found on the GitHub. And we should be able to connect this to HDMI. And I have some really short adapter cables here. This is going to have to do for testing. So this is an adapter from HDMI to HDMI, and this is mini HDMI actually on the Pi. So this now takes a regular HDMI cable, which I happen to have on my TV here. So this should now be connected as it should, and with the software in it. So let's try and fire up the Amiga and see what it does. Would be really cool if this just worked right away, which is a possibility, but also there's quite a significant possibility that I messed this up. First time I'm ever soldering SMD components this size, or this not size. Okay, fingers crossed. Do we get anything on screen? Oh yeah! There was our Pi signal there, and there's our Amiga signal. Hoo-hoo! Yes! We made an RGB to HDMI and it works! So my little SMD soldering adventure was successful. Yeah, that actually works. Yeah, I don't have any Amiga discs handy at the moment, so I'm not going to play Turrican. And also I don't have a joystick connected or sound. The one downside of these adapters is that they don't output sound via the HDMI. Obviously because they are only connected to the Denise. There are workarounds for that, using little boards that inject an audio signal into the HDMI signal and such. Supposedly works really well, but I usually use external speakers anyway. So I would connect external speakers to the RCA jacks on the Amiga directly to have sound. And I'm not too worried about not having sound through the HDMI. But the picture quality looks pretty good and my little board works. That was all I wanted to show you here. And I'm super happy that my first adventure in small-scale SMD soldering went this smoothly in the end. A bit of a learning curve, and I think there's still a longer learning curve ahead of me. One tip I can give you is to use way less solder when drag soldering than you think you should use. You need only very, very little solder. As I found out while breaking one of these logic chips, which is not a big deal really. I bought like 20 of them or something, so I have plenty to populate all the little PCBs I had made. I'm going to do that because there's a couple of Amigas I want to put these in. I really like these, and as I said, there's an updated version of this board with a CPLD that has some more options for fine-tuning. But in my experience and with my monitors that I tried with this simple version with just the logic chips works fine. So I guess that's it for today. Thank you very much for watching. Thanks for your thumbs and your comments and your subscriptions especially. And extra special thanks to everybody who supports me on Patreon or on Ko-fi or on the YouTube channel memberships page. These little projects would not be happening without you. So thank you very much for your support. Again, thank you to Tomlov for letting me try their microscope. You are going to see more of this in some future videos, I'm sure, because it is a really, really useful device for me. And as I said in the beginning of the video, there's links in the video description and also discount codes. So if you want one of these, please check out the links in the video description. That's it. I'm Jan Beta. Thanks for watching. See you next time. Bye.